Previously, you have learned about how we can control the ESP32 by using the Blink application. So today I will show different type of dashboard which is based on the ThingSpeak. So ThingSpeak was actually developed by MATLAB. So once we get the data in the cloud, we can use some sort of the analytical platform inside the MATLAB toolbox. So basically, the ThingSpeak will be quite different in terms of the in comparison with the Blink application, Blink platform, because of Blink is quite simple to program, and then most of the programming was done in the app side of the IoT platform. Whereas for the ThingSpeak, it will be a bit more complicated, just a bit, because of it involves something like the API calling protocol from the Arduino or the ESP32. So today I will cover up in terms of what is the detailed protocol, how we can read the API link that are generated inside of the ThingSpeak platform. So let's get started. So basically, this is some sort of the step on how you can develop or construct the ThingSpeak application. So the same with the Blink. So it comprises of the two main steps. So the first one is to create the ThingSpeak account. So for this particular case, so we can easily create the ThingSpeak account from this particular link. I just need to do simple registration process, and then later on we will once we log in, so we will have the ThingSpeak dashboard. I will show you later on in the details. So the step to create the dashboard is quite simple. So first thing first is that we need to create the channels. So channels is something like the unique ID that we will calling when we call the API links. It's something like the it's quite unique. That means that for every project that we create, we will be assigned a unique channel ID. And then second thing, the same thing, we need to add widget. So for the ThingSpeak, basically we have just 3 widget. This is more on the how we can show the data from the ESP32 directly to the ThingSpeak platform. So basically for the widget, the ThingSpeak consists of the 3 main components. So the first one is the couch, second is the numeric display, and then the third one is the lamp. So this is just the step on how we can create a ThingSpeak project in general the dashboard. And then the second part is the programming side from the client, which is in this case we will use the Arduino and also the ESP32. So basically what we can do is that we will develop some sort of the application software development on how we can call the API link. So I will show you later on in ThingSpeak. So what is the API link that you need to call to ensure that the controller can send the data to the respective field inside of the ThingSpeak dashboard. So this is the example that I will show you today. So this is some simple example of the rainwater harvesting system. So basically the system comprises of the two sides. So this is the client side, which is we have the controller and also a collection of the sensors. And then the second side, which is the dashboard side. So this is the ThingSpeak, in which it will display all the collected information from the sensors and then display that thing in the ThingSpeak dashboard screen. So basically for the ESP32, so it comprises of the 3 main sensors. The first one is the ultrasonic sensors. It was responsible in order to measure the water level inside of the rainwater harvesting tank. So I have shown you the concept of the ultrasonic sensor previously. So for this particular case, we just assign the field 1 ID to the ultrasonic sensors. And then second, we have the turbidity sensors. So as the name means that it was responsible in order to measure the water quality. So it's either means that if the turbidity value is low, means that the water is clear. If high, means that there's a lot of the other particle inside of the water. So we assign that thing as the field 2, and then the last sensors, which is the pH sensor. pH sensor will measure the pH value of the water, which is ranging from something like the from value maximum 1 to 10, something like that, because of usually the water is not very acidic. It's more to the alkaline side. So because of that, normally the ranging will be some sort of the between 1 to 7, something like that. In the ThingSpeak side, so we will create some simple gauge, and also we develop some graph to display all the output and the data collected around the time. So basically, the communication protocol from the ESP32 to the ThingSpeak port is based on the HTTP request. So I will show you some sort of the example on how we can call the HTTP request from PC, from some specific software called Postman, and also eventually we will code that thing, do the coding inside of the Arduino in order to call the HTTP request. So let's go to the practical side of this project. So basically, this will be the main screen of the dashboard. You can go to the thingspeak.com, and then after you perform the login, basically you will have this interface, which is the main dashboard. So in the dashboard, we can refer to the top side of the tab. So we have the channel. So channel is actually something like the for every project, so we create the new channels. So in this case, I have created the project of the rainwater harvesting monitoring. So means that once I create this project, so basically the unique channel ID will be given to this particular project. So means that if I have another project, I create let's say monitoring of the traffic flow, so I create another project, so means that I will be assigned another channel ID. So this channel ID is really important because it will be responsible as the unique route to send the data to the ThingSpeak dashboard. So this is the interface after I create the application of the rainwater harvesting monitoring system. So you can actually create your own dashboard later on. So basically, once we create the dashboard, so the next part is what we need to do is that we need to go to the so we have some sort of the multiple tabs here. So basically, inside of the channel, we have the private view. Private view means that we develop the dashboard only for our own view. So the next part is the public view. So public view is that once we create this particular dashboard, we can share with others. So means that in some situation, most of the time, the private view and the public view will be the same. But maybe perhaps you want to create the private view dashboard. You want to add much more detailed visualization. So means that it can be different from the public view. And then the next step is the channel setting. So channel setting is where you will actually set how many data that you want to transmit from the controller to the dashboard. So basically, for this particular channel setting, so the channel ID will be assigned to you. This is a unique ID from our main channel. Then the name is you can give whatever name. So this is just general name, and then some sort of the description. What is the application for this particular channel? And then this is the important part, means that you will have you can assign any census value from field 1 to field 8. So means that for this particular case, field 1, field 2, field 3. So field 1 is the water level. So in this case, water level was actually reading from the ultrasonic sensors. The second one is the turbidity from the turbidity sensors value, and then the third one is the pH value. So for this current version of the ThingSpeak, so you can assign some sort of the 8 field at one go. So you can call this, you can send the data to this particular field using just by one link. So I will show you later on how we can able to send the data to this particular area. So just for this case, for the time being, you just need to assign some sort of the value. The what type of information that you want to set in the field. So you don't have to worry. You can put any name here, because of when you calling the function in the Arduino or in the controller, so it will just call this field value. So means that it's either field 1, field 2, field 3. So basically microcontroller does not know what is the root, or what is the the specification of the field 1. So in this case, only the dashboard know field 1 is belong to the water level, field 2 belong to the turbidity, and etc. In the microcontroller, you just blindly send the value of field 1, field 2, and field 3. Okay, so the next part is the next step is the sharing. This is some sort of the how you can how you wish to ensure that the public view of the setting will be done. So you can share the channel with everyone, or you can share with specific person by giving the email address and etc. And then the next step will be the API key. So this is the most important things when you want to do the coding in the microcontroller side. So for this particular case, you will be given two type of the API key. So the write API key means that you want to send the data from the microcontroller to the dashboard. And then the second one is the read API key. Read API key means that a microcontroller send request to the dashboard, and then dashboard send the data, whatever data request by the controller. So there is the two different API key, the write and also the read. So how you able to do the coding? So basically, this is the API link that you need to call in order to ensure that you can send the data, or you can view whatever data inside of the ThingSpeak. So basically, if you can see from here, so all the request is based on the GET. So basically in the HTTP you have the GET, you have the POST request. So basically the GET request is the same when you do the browsing. So means that if you want to request for the Google, you just type www.google.com. So in contrast with the POST request, so the POST request means that you call the link, and then at the same time you will send the payload. So it will be something like if you want to log into some sort of the, let's say in the online banking, let's say Maybank, so you need to provide the username and password. So username and password will be the payload, and then you need to call the post instead of the get, so that you can call the link, and then at the same time you supply the payload to the link, so that it will be the authentication in the server side. But just forget about that thing. In the ThingSpeak, the most important thing is that all the request is based on the GET request. So the beautiful of this side is that for the GET request, you can actually test that thing by using the simple browser. So I will show you some sort of the example. So the API request in this example was actually directly linked to your application and also to the ID. So it means that this is the channel ID. So it will give the same channel ID number to the link, so that you can straight away try that particular case. So let's say for this particular case, if I want to read the channel field, so what I can do is that I can just simply copy this information, and then I can just paste that thing in the browser. So it will give me some sort of the detailed information about the data request. So let's see if I can zoom out this thing. So this is some sort of the when I call the request. So this is the information provided, which is the name, the monitor the application, and then also what is the data. So the data was actually arranged using some sort of the JSON formatting. So if you want to let's say display the data much more nicely, so it means that it's quite hard to read, but you can create the parser in order to parse the data. So there is some sort of the application that you can use in order to read this data nicely. So one of the application is based on this site. The name of that thing is the Postman. So Postman is some sort of the application that you can actually use in order to test the API link that given to you. So in some sort of the application, if you want to do the integration between two platform or two software, so the main communication is based on the API link. So maybe somehow people give you the API link, you need to try that thing first before you do the coding. So this is some sort of the software that you can use in order to create or in order to test that API link. So this is some sort of the my previous project that I have used this particular software in order to test some API link that given to me, and then I can see how the data transmit, how we can receive the data, what type the arrangement of the data, so that we can see that thing nicely. So for this particular case, what can I do is that we have some sort of the get, post, put, patch, delete, and everything. So this is the most important thing is something like get and post, and then I think some sort of application use the put. So this is the common one. So we use the get function, and then what we can do is that we can simply copy this link, the same link. So we receive the same raw data, but it can arrange the data nicely to you. So just the same thing, get, and then I press the send button. So once you press the send button, so this is the representation of data in the quite neat arrangement. So this is the original one, the raw one. The raw one is something like we receive in the browser. So the pretty view is something like we have much more data that arrange is quite detailed. So it means that we have the arrangement in terms of this is the header of this file in terms of the ID, the name of the application, and then some sort of the latitude longitude. This is the header, and then the arrangement. Field 1 is what the level. Field 2 is what. Field 3 is what. So in this particular link, if you look at this thing, so we actually call some function in which we give the we want just one result of 2. So you can change that thing. Let's say if you want to display 4 result instead of 2, so you can send the same request, and then later on in this case you have 4 readings, 1 2 3 4. So this is the same header. Header something like the how the data was arranged, and then what is the name, everything. So this is actually the field. So it means that this is the data in our dashboard. So the same thing, this is for the read channel. So this is what we will do today, is in terms of how we able to send data from the microcontroller to the dashboard. So the same thing, if you look at this API link, so I zoom out this part. Okay, for this API link, so basically what we have is that we have the HTTPS and also the ThingSpeak. So we have the API key here, and then later on API key. So the API key is the API key of the the right side, and then later on this is field 1, so we give the field 1 value of 0, so for this particular case. So if you can try this thing actually from the browser and also from the Postman. So let's say if I want to try this particular command, let's say first thing first, I try that thing in my browser. So can just paste, and then so in this case the field 1 value will become 0. So let me just open up the private view. So the first thing first is that the for the channel setting, field 1 is the water level. So in the private view, so it means that for this particular case, water level is here. So currently the value is 35. So I will show you. Let's see if I change the value of the field 1 to 10. So this is some sort of the just a simple function on how we can call this particular function. So it will update the value of field 1 will be equal to 10. So this is the value equal to 10. So let's say if I want to update the value of field 2 and field 3. Field 2 is actually the turbidity, and then field 3 will be the pH value. So for that particular case, I can just add some sort of the field here. So let's say field 2 will be equal to 20, and then I can add another one which is field 3 will become currently is 7. So let's say so 3 will become maybe 2. So field 1 will be, let's say 15. 15, field 2 will be 20, and then field 3 will be 2. So this is just a simple example. Then we enter that thing. So okay, so this is all the values. It means that 15, 2, and then 20. So the same thing, you can try this command inside of the Postman. So the same thing, that means that you can give whatever value. Let's say field 1 will be 25, field 2 will be 25, and then field 3 maybe 5. So the same thing, you can just send the command, send the request, and then it will give you some sort of. So field 1 25, field 2 25, and then field 3 will be 5. So we try to load that thing. Okay, so means that for this particular case, 25, 25, and 5. So this is some sort of the simple way on how you can try the functionality of the API link. So it's quite easy, it's quite straightforward. You just need to go to the API key, and then just give the corresponding API key to this particular. Just call this link, and then they will update the information in the channel. So what we want to do next is that so I've shown you how we can use the browser and also Postman in order to send data to the dashboard. So the next part is that we will do some sort of the how we can send this particular data by using the controller. I will show to you example. The first one is based on the Arduino coding, and then second one will be based on the Arduino coding using the Arduino, and then second one is the using the ESP32 to repeat the same process. So let's go to the first example. So this is the example of Arduino. The Arduino use actually the ESP01 to establish the communication. So for this example, since in the ThingSpeak example, I have some sort of the ThingSpeak has the library that you can call the function if you use the ESP8266. But unfortunately for the ESP32, ThingSpeak does not have any built-in library. So for that particular case, you need to create your own HTTP post. So let's say in the first stage, let's focus on this thing. So means that let's say if you use the ESP82 something. So for that particular case, we have the library. So I can use the ThingSpeak.h library. So what we will put instead of the coding is that first thing first is that just give some sort of the channel number. So this is the channel number. How you can get that thing is actually from here. This is the channel ID, and then later on the right API key. So API key as I have shown you previously. So API key here. So the right API key and the read API key. So that is this part. Just put that thing, and then later on let's browse some sort of the example here. So this is quite pretty straightforward. So it means that this is the initialization. So for the setup, so this is the first initial setting. So in general, starting from configure Wi-Fi, so it means that this is the function that is responsible to establish the internet connection, the Wi-Fi internet connection, to the from the microcontroller. And then if let's say this is configure Wi-Fi, so configure Wi-Fi is more the standard protocol, standard way on how we can communicate with the shell and also establish the communication. So once Wi-Fi is okay, so the next part is that the ThingSpeak. So only after the Wi-Fi was connected to the internet, so we can actually begin the ThingSpeak communication. So this is for the setup. So the next part is that for the looping. So this is for this particular example. So we just read the data in every cycle, and then we will only send the data to the ThingSpeak server every 30 seconds. So for the first part is this is just a pretty standard method on how we can read data from sensors and display that thing in the LCD. So I just skip this part. So the important part is here. So it means that after 30 seconds, for this case, after 30 seconds, so we will begin the process of sending the data to the ThingSpeak server. So the first word is we configure the Wi-Fi. So we check the Wi-Fi connection and then establish the internet connection from the microcontroller to the internet. So if connection was established, so the next part is that I call the client test function, which is give the sensors reading. Sensor reading is actually the ultrasonic reading, the turbidity value, and also the pH value. So let's go to this function, means that this is the client test. So for the client test, so since I use the library converting speak, so it will be quite straightforward. So what we can do is that just type the ThingSpeak.set field. So field 123 is the field number. So as I have mentioned previously, so in the channel setting we have field 1, field 2, and field 3. So this is all the number. So field 1 will send the ultrasonic value, so it will be corresponding to the water level in the ThingSpeak. And then field 2 is the turbidity value, so the same thing here, the naming convention, turbidity. And then field 3 will send the data of the pH that read from the sensors, and then send the thing to the ThingSpeak server. So and then using this library, so it will just ThingSpeak.write field will send the information regarding the channel number. So this is the unique channel number of our ThingSpeak channel ID. And then later on, this is the my write API key. So the same thing, the API key, we just supply that information. So usually after the update is success, so we receive the value of x equal to 200. So it's stated that the operation is actually completed. And then one of the most important thing, it will require some times in order to process to be completed. Once you send the data from the controller to the dashboard, it will require some times in order to perform to execute the process. So for that particular reason, we need to ensure that we give the sufficient delay in order to process to complete it. So for this particular case, I give around 20 seconds for the process to complete it, because we send all the three data. It will be updated in the server before the server will give the ping information, which is the 200, the code of 200, stated that the operation was actually success. So this is the whole things regarding on how we can use the if we use the ThingSpeak .h library. So please do remember, so if we use any variant of the ESP8266, so means that we can use this library. But in some situation, perhaps we have the controller, we have the something like ESP32. So unfortunately, the ThingSpeak does not have any built-in library for the ESP32. So for that particular case, we need to use the general protocol on how we're able to call the HTTP function from the controller. So I will show you in our next example by using the same arrangement. So this is the previous one. So I will show you right now the second example on how we can do the coding. It's quite very general coding. Uh, in this case, I use the ESP32. So for that particular case, we don't use any ThingSpeak, any built-in library from ThingSpeak. So this is just the general protocol. So what we will do for this particular case is that we will call the API link straight away. The same thing that we have done in the browser and the Postman. So it means that we just rearrange that thing so that it will be visible from the side of the microcontroller. So the detail of this example you can find from this particular link. Only if in this link, the example show on how you can update the information from the single field. So I modify the information a bit so that it's able to send the data into straight into the three field. So basically, let me just give a brief overview of this particular coding. So for this library, so for this platform, it will use two library. The first one is the general Wi-Fi function, and then the HTTP client, just two library. So we don't use any built-in ThingSpeak library. So it's quite pretty straightforward. So it means that first we need to supply the server name. So this is the standard, the API ThingSpeak link, and then we need to supply the API key. Please do remember that this is the API for the write key, because of we want to update some information in the ThingSpeak server. Okay, let's go to the setup. So setup will be straightforward. So it means that first we establish the Wi-Fi connection so that the Wi-Fi will be connected to the internet. So only if after the process success, so means that the system able to connect to the internet, then it will proceed to the next stage. So this is just in the setup. Uh, so this is the most important part. So for this part, in the looping part means that it will wait every 10 seconds before it will update the information in the ThingSpeak server. So basically, what the code do is that after 10 seconds, so it will check the status of the Wi-Fi. If the Wi-Fi is connected, then only we will execute the whole process. If the Wi-Fi is not connected, just give the information Wi-Fi is disconnected. Actually, you can create some sort of the function later on, means that if you detect Wi-Fi is connected, then do the connection again. So the same thing with the we just can copy the some code in the setup, and then we can paste that thing here if Wi-Fi is disconnected. Okay, so now once Wi-Fi is connected, so the next part is that we call the HTTP protocol. So this is the pretty standard method inside of the ESP32 or any variant of the microcontroller on how you can call the HTTP protocol. So just need to supply in terms of the server name, okay, and also what you can modify is that for the site. So this is the side you can do the modification. So this is the field 1, field 2, and field 3. So currently, because of my ESP32 does not directly connected to any sensors, so I just give the random value. So for the field 1, for the water level, the random value will be maximum over the 200. And then second thing, for the turbidity, maximum value will be 500. And then for the field 3, random value will be around 10, because this is the pH value. So this is just display and then concatenate all the information regarding the sensor value. So this is the most important part. So this is how we establish the string. So means that we merge all the data. The first one is the API key, and then this is the field 1 uh, plus its corresponding value, and then field 2 is corresponding value, and then field 3 is corresponding value. So we just merge every value in one long string. So this is just the string for the request. So means that we still not calling any HTTP yet. So we construct the string. So the string, you can imagine something like the link that we want to call. We just merge that thing. I've mentioned previously, if we want to add the field 2, field 3, we just need to add some more in terms of the string of the field and also the value. So the same situation here. So this is the part that will be responsible in order to merge every field value with respect to the API key and also the HTTP calling function. And then this is the part where you will do the request, means that all the string that was merged here, the longer link will be post in this function, means that http.post, it will send all the request data that we have created previously. So it will call the function of field 1 and field 2. And then so as I mentioned, so normally it requires sometimes in order to update the server. So because of that, we need to give a sufficient delay. If you let's say if your delay is too small, so means that there is some tendency that not all the field data will be updated, or it will be haywire in the, you will see something like you have different data in the client side, and then the data updated in the server side will be quite different. So that's one of the reasons that you really need to give some sort of the very sufficient delay time in order to server to complete the updating process. So this is just the coding, and then after all the process completed, and then we will close uh, the calling protocol, the HTTP protocol. And then later on, the process will be repeated every 10 seconds. So I will show you the real example on how this was executed because I have the ESP32 with me right now. So I will upload the coding, and then we will show the details on how the data will be updated in the server. So this is data, so I will just show the gauge, this part. Okay, and then I will, let's say, compile this part and then do the upload. Okay, so the compiling is completed, so we can do the upload. Okay, so now we can see the status of the serial, and then later on it will update the data. So in this case, water is 156, turbidity 456, and then pH equal to 3. So the data was updated in the ThingSpeak server. So let's wait for the another data for another 10 seconds. So you will see all the data here. So 199 for the water level, 109 for the turbidity, and then 0 for the pH. So the data was updated. You can see some sort of the delay. Once we send that thing, so it will require some time for the server to process that thing to update in the gauge. Okay, let's wait for another two data. So 83, 51, and then 1. So it will update that thing here. Okay, 83, 1, and then 51. So let's say for the final data, 195,387, and then page 0. Okay, so this is the whole process on how we can do or calling the request. I have three into example. The first one is using the built-in library of the ThingSpeak, and then second one is actually how we can do the HTTP calling using the general link. So let me close this part. So the data will be updated every 10 seconds. So one thing regarding the dashboard is that once you create the private view or the public view, you can add some sort of three things. You can add the visualization. Visualization is more something like the graph and etc. The histogram, and then you can add some widget. So for the ThingSpeak, we have three widget currently: the gauge that show the value, the same thing with the numeric display, and also the lamp indicator. So just three information. It's quite simple if you want to test some functionality. But the most important thing is that in general, you know how you can call the API link from the controller. So you can try that thing. So means that if you know how you can call the function from the browser, you can use either PC, you can use whatever controller, Raspberry Pi, or whatever Latte Panda. If you know how that thing works in order to call the HTTP protocol, and then straight away you can manipulate the link and then send the data straight away. So basically, that's it in terms of our class this week regarding the how we can use the ThingSpeak to create the simple IoT dashboard. So I will provide you the coding, everything so that you can try yourself, create the dashboard, and then you can try the code with your own microcontroller. So I think that's all. Thank you very much.